Last section from this unit, we're going to talk in section 4.5. So this is just going to turn our attention now. We've spent the whole unit talking about systems of numeration, their development, then extending what we know about place value to other bases. And what we're going to end with is ways that people, just two different ways basically that people throughout history have done multiplication. Adding is pretty straightforward most times in even in like the additive system of numeration or any of them. You just add up all of the symbols, but multiplication becomes a little bit of a issue, and that's why place values notation is so good. So we're going to talk about two different ways to multiply. The first one is a pretty early system for multiplying things together. It's a system called duplication and mediation. Okay, we have calculators now, so we wouldn't use this now. No one in the world does this anymore, but this is an older thing. The second method, there are still areas of the world, particularly China, that will use the second method that we're going to talk about. So here's what you do with duplication and mediation. So what we're going to do is we're in example 1. I'm going to work this one with you. We are going to multiply 39 times 23. Okay, so what I'm going to do is I'm going to create two columns, each with a heading, and the first one's going to be a heading 39 and the second one's going to have the heading 23. Okay, so that's how we start. Doesn't matter what order, you could just as easily perform the duplication and mediation with the 23 on the left column and the 39 on the right column. It's not going to make a difference. But once you've assigned them a column, you're going to do something different with the left column than you're going to do with the right column. On the left column, that's going to be our duplication column. And what that means is what we're going to do with this number 39 is we're going to successively divide it by 2. Okay, so we're going to divide by 2. And then we're going to drop any remainder or any decimal. I don't care about any fractional parts. So we're going to divide by 2 and we're going to truncate any fraction. Now, in case I did not explain that well and you have no idea what that means, here we go. When I divide 39 by 2, and you're welcome to use your calculators, even though the reason this system was invented is because people didn't have calculators. So the intent was to make it so you didn't have to actually multiply these numbers. It's going to boil down to adding things at the end. But you can use your calculator. When you divide 39 by 2, you see that 39 divided by 2 is going to give you 19.5. Okay, so all I care about in that is the 19 part. That's what it means to truncate. So I don't care about the 0.5. So 39 divided by 2 is 19.5. So I'm just going to write down 19. Okay, 19 divided by 2. What is 19 divided by 2? Perfect. I can wait you out. That's what they taught me in teacher school a long time ago, is not to answer my own questions. So yes, 9.5. So again, I don't care about the 0.5 part. I'm just going to write the 9. 9 divided by 2 is 4.5, but I just care about the 4 part. And what you're going to do is you're going to duplicate all the way down until the last row is a 1. So 4 divided by 2, 4 divided by 2 is 2, so I'll use that. And then last but not least, 2 divided by 2 is 1. So I've divided by 2 successively until I end up with a last row of 1. Everybody tracking with me so far? You're going to get your chance to do this 2 times. It's going to be the exact same thing. Now what I'm going to do is for each of these rows that I now have, I'm going to come over here to this side and I'm going to double this. So I've divided this one successively by 2. That's duplicating. The mediating is I'm going to take the 23 and I'm going to double it for every entry. So 23 times 2, or 23 plus 23, that's going to give me 46. 46 times 2 is going to give me 92. 92 times 2 is going to be 184. 184 times 2, that's going to be 8, and then 16, so that's going to be 368. And last but not least, 368 times 2, that is going to be 16, carry the 1, 13, carry the 1, and then 736. So on the left side, I divided by 2. I ignored any remainders. On the right side, I doubled it. And you might be thinking, well, how in the world are any of those numbers going to get me the answer to 39 times 23? Great question. Here is the next step. Oh, let me write this down. On this side, I multiplied by 2 each time. Then what you're going to do is you're going to cross out any row that has an even number on the left. So we're going to cross out any row beginning with an even number. So 39 is an odd number, 19 is an odd number, 9 is an odd number, 4 is an even number, so I'm going to cross out that row right there. 2 is an even number, so I'm going to cross out that row right there, and then 1 is an odd number. Notice I'm not looking at the numbers on the right when I make that determination. I'm looking at the numbers on the left. And then last but not least, to get the answer to what is 39 times 23, you're going to add up the numbers on the right that remain. So I'm going to add up the 23, the 46, the 92, and the 736. And when you add those 4 numbers up, you are going to get the answer, and we'll verify with our calculator. That will be the answer to 39 times 23. So on the test, I'm going to have you do this. And I know you can use your calculator to verify. I have no problem with any of that. What you got to show me is the work. Okay, so I'm going to ask you to show me the work for multiplying 2 numbers by duplication and mediation. Okay, so I'll be looking for this. So I add this up. 3 and 6 is 9, and 2 is 11, and then 6, that's 17. So I'll carry the 1. And then 3, 7, 16, 19. Carry the 1, and I have 8. So that should be hopefully 897 if I have done all of my busy work correctly. So here's my calculator. Let's see what modern technology will tell me much faster. 39 times 23 is 897. So I don't know the clever mathematician that invented the duplication and mediation method, but it works. So there you go. So what I would like you to do is exercise 1. I want you to run through 56 times 27. Just so we're all doing the same thing, I'm going to make 56 the left-hand column and then the 27 the right-hand column. If you need me, raise your hand. I'll come to you. I'll help you any way I can. All right, let me start my busy work. If you're working, keep working. We'll compare notes at the end. So my duplation column, starting with the 56, I'm going to successively divide that by 2. So 56 divided by 2 turns out to be 28. 28 divided by 2 turns out to be 14. 14 divided by 2 is 7. 7 divided by 2 is 3.5. I only care about the 3 part. And then 3 divided by 2 is 1.5. I only care about the 1 part. And then I'm down to where I need to be. So for each of those rows that I've just created, I am now going to take the 27 and I'm going to double it. So 27 times 2 is going to be 54. 54 times 2 is going to be 108. 108 times 2 is 216. 216 times 2 is going to be 432. And last but not least, 432 times 2 is 864. Now, before I finish this problem up, did I make any mistakes, or do you have a different number than me and we need to figure out why? Is that okay? Does anyone not understand where any of those numbers came from? All right, well then now, just as I mentioned before, I'm going to cross out any rows that start with an even number. 56 is an even number, so I'll get rid of that. 28 is an even number. 14 is an even number. The rest of the numbers are all odd, so I'm going to add together the 216, the 432, and the 864, and then we'll check. But that should add up to be whatever 56 times 27 is. So 6 and 2 is 8 and 4 is 12. So a 2, and I'm going to carry the 1. And then 1 and 1 is 2 and 3 is 5 and 6 is 11. And then I'll carry the 1. And then 3 and 7 and 15. So I think we should get 1512. Let's see if my calculator verifies that fact. So 56 times 27 turns out to be 1512. Great. Excellent. All right, one more time, just to practice. Yeah, what's up?
When we cross out, you said this right hand number has to be equal?
The left hand number. Did I, if I said right, then I misspoke. The last number, what makes a number even is it ends in a 0, 2, 4, 6, or 8. That means you can divide 2 into it evenly. Okay, that's why it's called an even number. If something ends in a 1, 3, 5, 7, or 9, it's an odd number. Okay. No, it's okay. That's a great question. It's great to be clear on these things. Yes, so 56 is an even number, even though the number 5 is odd. It all matters on what that last digit is. Okay, great question. All right, so I'm going to give you a couple minutes. Go ahead one more time. Do the same process of duplation and mediation with 112 times 134. 112 times 134. I don't remember if I said the 134 or just 34. All right, let's see how you did. Let's write these numbers down. If you're working, keep working. So 112, when I divide that by 2 is 56. And then 56 divided by 2, we saw in the last problem is 28. 28 divided by 2 is 14. 14 divided by 2 is 7. 7 divided by 2 is 3.5. And 3 divided by 2 is 1.5. So now I'll double 134 each time. So successively, 134 when I double it is 268. When I double 268, I get 536. 536 when I double it is 1072. 1072 when I double it is 2144. When I double that, I get 4288. And last but not least, when I do that, I get 16, carry the 1, 17, carry the 1, 5, 8576. Again, did I make any arithmetic mistakes right there? I'm not using a calculator. It's always dangerous for me to be doing mental arithmetic. All right, so then I'm going to cross out any of the rows that have a number on the left that is even. So the 112, what we started with is even. The 56 is even. The 28 is even, and the 14 is even. So one final time, I'm going to add up those numbers, and that's going to give me the result for 112 times 134. So we get here 12, that's 18, carry the 1, and then 5 and 13 and 20, carry the 2, 3, 4, 5, 10, carry the 1, and then I have 3, 7, 15, 15,008. We good? All right. I feel fantastic about it. Everybody feel decent about that? The homework has 2 or 3 or 4 of those. Practice a few more times. I'm going to put 1 or 2 of those on the test that you're going to take next time just to see if you remember. So the other historic way that multiplication became developed so the tool for multiplication is called the lattice method. I've seen it called other things, just depends on where employs it. Like I said, this is the way they actually, I think in China, use this in elementary school in order to teach multiplication. And here's what the lattice method entails doing. Okay, we see that I want to multiply 312 times 75. So I'm going to create a rectangle, and that rectangle is going to have the same number of columns as this number, and then the same number of rows as that number. So I'm going to have 3 columns and 2 rows in my rectangle. So it's going to look like this. So here's my rectangle. Here's my 3 columns. And then here's my 2 rows. And what I'm going to do with the 3 columns is I'm going to label each with the digits from the first number. So I'm going to put a 3 over this column, a 1 over this column, and a 2 over this column for my 312. And then for my 2 rows, I'm going to label the rows with the numbers from the digits from the second number. So I'm going to call this one 7 and this one 5. Notice the orientation. I've put the 3 digits at the top. I've put the 2 digits on the right. Okay, that's important for this method. And then I'm going to do one more thing, and then I'm going to pause for breath so that everybody can catch up with me. Now, the reason this is called a lattice is I'm going to take that rectangle with those boxes, and I'm going to create what looks like a lattice. I'm going to draw a diagonal in each of the boxes that I have. The diagonal is going to go from the bottom left to the top right for each of them. And so whoever thought of this method, basically this is the same way we multiply with our stacking. It's just structured different. That's all. So like basically this was a step to get to our present notation. That's why we use our notation now. This, at some point in history, this was the common way to multiply. And then somebody said, okay, it's a little more efficient to just write it like we write it now. Or at least somebody thought it was more efficient. Okay, so here we go. And so what we've done is we've divided this up into a series of 1-digit multiplication problems. So 2 times 7 is what? 14. So I'm going to put the 1 above the diagonal and the 4 below the diagonal. And you do that for each pair. 1 times 7 is 7. So what would you guess I'm going to put above the diagonal if the result is just 7? A 0 above the diagonal, a 7 below the diagonal. 3 times 7 is 21. So a 2 above the diagonal, a 1 below. 3 times 5 is 15, so a 1 above and a 5 below. 1 times 5 is 5, so 0 above, 5 below. And then finally, last but not least, 2 times 5 is 10, so a 1 above, a 0 below. And then what you do to get your answer is now you just add along those diagonal lattices. So this first one, my units place, is going to just be 0. I'm going to write that right here. Then my next place, my tens place, is going to be when I add these numbers. So I'll draw a little arrow right here. I just don't want to make a big mess out of this, but I'm going to add the 4, the 1, and the 5. So 4 and 1 is 5, plus 5 more is 10. So I'll write a 0 there, and I'll carry the 1 up to the next diagonal. 1 and 1 is 2, plus 7 is 9, plus 5 is 14. So I'll put the 4 there. I'll carry the 1 to the top of the next diagonal. 1 and 1 is 3, and then it starts with a 2. And then your answer is just those numbers that you read on the left and the bottom. So the answer to this is 23400. So in other words, 23,400. That's the lattice method. If you got a question, comment, concern, I'm open to them. In the meantime, flip the page. Flip the page to the next exercise. We're just going to do the lattice method a couple times because this is really the end of the section. I got one other thing I'm going to mention to you, but there's not really anything for you to do with it. I'm just going to tell you something about what the lattice method enabled people to be able to do. So go ahead, exercise 3, do the lattice method to do 427 times 83. All right, you keep working. I'm just going to get started doing the arithmetic, and then we'll compare numbers. And if anybody has something different, one of us is wrong, and we'll figure out why. So I'm just going to start filling in numbers here. So here's my lattice. 4 times 8, I'm going to have that as 32. 2 times 8 is 16. 7 times 8 is 56. 4 times 3 is 12. 2 times 3 is 6, and 7 times 3 is 21. And now when I add along my lattices, my last digit, my units is 1. My tens, 6 and 2 is 8, and 6 is 14, carry the 1. And then we've got 6, 12, 14, carry the 1. 1 and 1 is 2, 4, 5, and then finally 3. So reading around the edges, I've got 33,000. 441 as the answer. Did I make any mistakes, or do you have something different than I do and we need to figure out why? What's up? 35,000. Yes, so see, I made a big mistake. I just read my number wrong. It's 35,000. Sorry about that. But it's good. It's always good to verify that y'all are still awake. So appreciate that. All right, if you got a question, ask it. If not, I'm assuming that you're ready for the next problem. So let's do the next one. Go ahead and do the lattice method. My purpose in this problem is just I changed the size of the numbers so that you have to make sure that you understand what size lattice to actually draw. If you have a question, you need me to come to you, please raise your hand. I will hustle right over. All right, so once again, let's see how you did. My purpose for this problem again was I changed the size of the numbers. We've got a 4-digit number times a 3, so I need to have 4 columns in my lattice. I need to have 3 rows in my lattice, so that changes the size, the dimensions of our rectangle. But the process is identical, so I'm just going to start at the top left. 1 times 2 is 0, 2. And then 1 times 3 is 0, 3. 1 times 9 is 0, 9. 3 times 2 is 0, 6. 3 times 3 is 0, 9. 3 times 9 is 27. 7 times 2, 14. 7 times 3, 21. 7 times 9 is 63, if I'm remembering my multiplication tables properly. And then 4 times 2 is 8. 4 times 3 is 12. 4 times 9 is 36. Okay, so there we go. Now I'll add everything up. My units place is 6. 2 and 3 is 5, plus 3 more is 8, nothing to carry. 8 plus 1 is 9, plus 1 is 10, 16, that's 23. I got a 2 to carry this time. And I carried it to the wrong lattice, so that's good that I caught that before making a dreadful mistake. 2 plus 4 is 6, plus 2 is 8. That's 17, that's 19, that's 28. Carry the 2. 3, 9, 12, and then 3, and then 0. 0 being first, I don't need to worry about that. That just means that I don't have any millions on this problem. So the answer is 328,386 if I've done all of my arithmetic and adding correctly. Anybody got a dispute? All right, then last problem. Just slide the page up. One more. Go ahead and do that problem with those two numbers, please. All right, so I've got a lattice here. I've got 5 columns because of 27,612. I've got 3 rows because of the 795. So filling in the blanks, 2 times 7 is 14. 2 times 9 is 18. 2 times 5 is 10. 7 times 7 is 49. 7 times 9 is 63. 7 times 5 is 35. 6 times 7 is 42. 6 times 9 is 54, and 6 times 5 is 30. 1 times 7 is 7, 1 times 9 is 9, 1 times 5 is 5. And then the last one, 2 times 7 is 14, 2 times 9 is 18, 2 times 5 is 10. So just went through all the single digit multiplication right there. And so now the rest is just adding up these lattices. So I've got 0 as my units. 8 and 1 is 9, and 5 is 14. Carry the 1. Then I've got 1 and 4 is 5, and 1 is 6, and 9 is 15. Carry the 1. 1 and 1 is 2, and 7 is 9. and 4 is 13, and then 16, and then 21, carry the 2. And then 4, 9, 12, 15, carry the 1. 5, 14, 28, 29, carry the 2. 6, 10, 11, carry the 1, and finally 2. So there's all of my digits. And then when I go around the side, I've got 2, 1, 9, 5, 1, 5, 4, 0. And so that means that I've got 21,951,540. All right, so that's the material I expect you to know. One thing I just wanted to mention, we use calculators. Everybody's always wanted historically to find easier way to do things. And so on the back page, a mathematician named Charles Napier, I don't know if he invented the lattice method or if he just invented the next step, but he invented a really early way to have a tool to help you do multiplication pretty quickly. And so what Napier did is he created these rods. Actually, he used leg bones from animals because that's what he had. Later they used stone tablets and things like that, but he created rods, multiple ones, of the multiplication table. So for instance, this rod that has a heading 9 is the times 9 multiplication table. So 9 times 1 is 9, times 2 is 18, 9 times 3 is 27, 36, 9 times 5 is 45, etc. We got 54, 63, 72, 81. And he could have as many copies of these as he wanted. And so then if he had to do something, now you don't have to write this down. I'm not going to make you do this on the test. There'd really be no way for me to be able to do that. But what he would do is if he wanted to then multiply 7 times 367, what he would do is he would lay out the rods for each of 3 and 6 and 7 side by side for 367. So I'm just going to do this because I feel like I need to be an instructor for just a second. So he would take the rod for 3. And then, so that's going to be the one for 3. Then he'd lay it next to the rod for 6. And then he'd lay it next to the one for 7. Okay, and so note it. So each of these rods just represented the multiplication table. So give me just one moment to divide these up into 9 parts. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Same thing here. Because he didn't on his rods, he didn't have a row for 0. He just had the rows for 1 through 9. So that would be why. I guess I don't know. That's a really great question, though. I don't know if he had a placeholder for 0, because if you did have like the number 307, you would need something there. So that's a good question. But as far as I've been told or looked into this, I don't know what he did with the 0. So So all I'm doing here is, and what you're kind of bored watching me do is I'm just reproducing. What I should do is I should go back into the file and do some copying and pasting and do that and make it look a whole lot better and more professional. So sorry about that. Oops, sorry. 03, 06, 09, 12, 15, 18, 21, 24, 27, and then we've got 6, and then 12, and 18, and 24, and 30, and 36, and 42, and 48, and 54. And the final one, we'd have 7, and 14, and 21, and 28, 35, 42, 49, 56, and finally 63. Okay, so all of that to labor the point that if he wanted to multiply 7 times 367, he would lay out the rods for 3 and 6 and 7 right next to each other in place value notation. Then he would look at basically all he was doing is he's creating a lattice, and he'd look at the row for 7, and he would use that to be able to multiply fairly quickly. So the whole point that I'm trying to draw your attention to is the lattice method enabled someone to make a tool, one of the first tools to be able to multiply fairly efficiently. So when you did that multiplication, what we would have is we'd have a number that ended in 9. And then we'd have 4 and 2, that would be 6. And then we'd have 4 and 1, that would be 5. And then we'd have 2, and we'd have 2569 would be the answer to that. And you could see how he could do that pretty quickly and easily. So I just wanted to draw your attention to that as a final thing. There's not going to be a test question on Napier's rods. I'm not going to have you draw that. I'm not even going to quiz you on the term. I just wanted to broaden your horizon on the development of math as we finished out this section.